Hi, everyone, and online. Welcome to another April meetup for OWASP Ottawa. We've got two great talks this evening. We have Timbits and a sticker table. So if you're at home, maybe next time we'll have Timbits and a sticker table for you too. I just want to mention a couple of things about the PSA slides. I'm just going to find a clicker. We would be very interested in hearing your presentation. So if you have an idea to talk about anything related to security, we take talks on any particular format. They can be a lightning talk of about 15 minutes, a 30-minute-ish sort of thing, or a full presentation with an hour with Q&A. We have an online site that accepts submissions, including details, your details, so we can use that in advertising the presentation. So we have a continuous call for speakers. And that doesn't work now. So despite testing this before, oh, maybe that's it. There we go. We have a Slack. If you're looking for a job or you're have a job to advertise, we have a jobs channel on our Slack. The OWASP executive director has regular office hours, so you can book time with him through his Calendly link. Our Slack has a self-register link, which is, OWASP's site has a self-registered link, which you can join the OWASP Slack through this link. I want to thank all of our volunteers who help make OWASP Ottawa possible, either from putting the PSA slides together, helping keep me sane, or helping us set up with the music and things like that. Yeah, I know, you can laugh. You have a big vat of coffee there. I'd keep an eye on that if I were you. OWASP, they do a lot of stuff. So there is Global AppSec DC and GSOC 2023 currently scheduled. OWASP projects, they've got some. These are some of the more recent releases, including Amass, which is one of my favorite tools. If you want to ever get creeped out, use Amass. This evening, we've got two great presentations. One related to DevSecOping. Is that now a verb? DevSecOping your way through compliance, and using Burp in testing GraphQL APIs. In terms of our meetups, we try our best to have a regular monthly meetup here, typically the third week of every month. And so we try to have that regular cadence. And before COVID, we used to occasionally have a meetup in Canada. So we've had one in Canada as well last week, and we're going to try to have a quarterly cadence with that. And I think those are the main things I wanted to talk about. These are our social links, so if you need to reach out to us or see what's going on, we have our Bird site, also known as Twitter. We're on Mastodon, just to avoid a lot of Twitter. And we have our own Slack site. Not because we want to be different than the OWASP Slack site, it was just we were there first, so we just had our own Slack going. Now it has a self-sign-up link, but it's in Heroku, and Heroku's giving me some grief right now. So hopefully that will be back up soon. And we're on LinkedIn, and in case you're watching this, in 5 years, you'll be watching it probably on YouTube. So We have a YouTube channel with all our past content, or most of our past content, curated by year and subject area. And I think that's mostly what I wanted to talk about in the PSA slides. But what I'm going to do is introduce our first speaker. Simon started out as a network engineer or network administrator, and somehow, I don't know what the gateway drug was into security, but somehow he then got involved in risk and security, working for banks and now insurance. So we all know that compliance is often a required thing, and it's sometimes not easy. But what if we can automate as much as we can to be able to try to tick most of those boxes so that we make life easier for everyone, and it will become a much happier place. So before I won't gibber on anymore, I will pass the mic to Simon. Set up your slides.
Can you hear me? A little bit. Yeah, like this is good? Okay, awesome. Thanks, Cart, for the introduction. It was, you actually saved probably 2 minutes of my intro. So no, this is all good. This is all good. So hi everyone, good evening, and for those online, I don't know which time zone you are at. A good time of the day for you. So we have quite a few people, which I'm really happy about. So before we start, and my apologies in advance, so I'm gonna be asking some questions. So don't be quiet, and please participate. First of all, I'd like to know you a little bit more, and can I ask you if you are a developer or close to development, can you raise your hand? Okay. Okay, all right. So current, it doesn't matter. All right, covering developers. Good. What about security? Who are in security? Okay, excellent. So we have like 50-50 split, which is good. So because my presentation today is going to be about DevSecOps and how to pass compliance audits with DevSecOps. And I think I'd like to cover both sides of the house, like from a development lens, and then also from a security, we call them GRC, governance, risk, and compliance, like that type of security, so that hopefully it resonates with all of you. All right, so a little bit about myself. So here I am. So at work, as Gart mentioned, I started as a network engineer and moved to security, audit, compliance, risk, you name it, and kind of stayed there. I had different roles over the past 17 years, and currently I'm at one of the insurance companies in Canada, and I manage a team of information risk, security, application security consultants, analysts, and a lot of what I'm going to be talking about today is what actually my team does at work. So I'm happy to share some of this experience with you. And outside of work, I'm a you can find me in bushes, camping, canoeing, you name it. I'm also I like volunteering. I'm a past president of Ukrainian National Federation here in Ottawa, and some of you I know attended as guest speakers our events in the past. And I also like travel, photography, books, other crazy things. All right, let's talk about DevSecOps and why we need it, what it is, and how it's done. First of all, once upon a time, it was, probably golden age of security. That's when it was before Agile, it was before DevOps, DevSecOps, and it is called waterfall. And so for those of you who don't know what waterfall is, it's project management methodology, which actually resembles waterfall because guess what? We started planning, then we go to coding, then we go to testing, deploying, and it goes like this. So it's very sequential, right? And if we are lucky, we add security in, just right before deployment, if we're lucky. Now, all of this would take anywhere from 12 to 18, maybe months, maybe 2 years. So we had all the time in the world. That's why I call it golden age, because security was pretty laid back and, had like maybe 3 months to do all the testing, penetration testing, vulnerability testing, and things like that. But then this happened, okay? This happened, and right before, I guess in mid-2010s, Agile came, and all those sprints, daily stand-ups, retrospectives, and scrums, Kanbans, and I hope I'm not just throwing jargon here, so you can relate to it with you, which changed things drastically. And so it was no longer waterfall, it was agile. And the big difference between waterfall and agile is that agile delivers in small increments. So we deliver, we iterate, and it goes like this. So obviously, security was kind of behind with the mindset, with culture, with understanding, with skills, technologies, and that became a problem. But let's take one step at a time. So development and operations, and by operations I mean infrastructure support, your networks, your servers, your databases, your containers, you name it. They have been for years incentivized differently. And so one of my questions for you is, what do you think is the big incentive for developers? What are they driven? So what's their goal? Sorry? Shipping. Okay, good. So developers, yeah, it's delivery, it's new software, right? It's all about change. So developers want to bring changes because that's what business wants. We don't want to maintain status quo. We want to, innovate. We want to deliver new products to our customers. That's change. Now, what about operations? No change. Exactly. Why? Yeah. No changes. Exactly. I remember my old days when I was network engineer and I had to support Active Directory in some servers as well. And I remember, we hated developers. We hated them because, yeah, they want to implement a new framework. They want to install their application. And guess what? It would crash our servers, right? So because operations is all about stability. Because if I do my job well, everything is good. I don't have to wake up at night, right? So that created a problem, right? And it's a similar problem with security because development and security, they had different goals. And what's the solution? This shiny DevOps with stars. Yeah, DevOps is kind of, you kind of combine the two worlds together, right? And so I use DevOps and DevSecOps, and really DevOps was missing security, and we'll get there, right? But when I say DevOps, DevSecOps, I really mean the same thing, right? So that was the solution. And I like this quote from one of the senior program managers in Microsoft. He said that DevOps is a union of people, process, products to enable continuous delivery of value to our end users. There is no software here. So when we talk about DevOps or DevSecOps, we don't really talk about software. It's more about culture shift, right? And it's important to understand, developers get it. With security, it's a little bit difficult. And I found with my own experience, with my colleagues' experience, it took some time to kind of get there. And that's why it's important to understand. Now, so what is DevOps? Let's get to the sources. I like to go to the sources. And the source to me is a DevOps handbook, which was written by Jim Kim, John Willis. Not very good with names. There is actually have a cover. So, and I believe there is a second edition as of November 2021. So it incorporates security, privacy, all those things that we were going to be talking about. And so really DevOps is three things. First is flow. We want to get from here to there as fast as possible. Second one is the feedback. So we want to get that feedback. We have an application running in production. We want to get all the telemetry from that application and feed it back to our requirements, right? So it's a continuous loop. And we also want to be able to experiment. We want to be able to learn. And that means no blame culture, high trust. And that is really key. Okay, so what about security? So I already mentioned we were in big troubles, sometimes are today. So let's talk about the ratio. So can you guess, like for every 100 developers, how many operations people are there? Okay, 2, 5, more. All right, so okay, let's say it's 10, right? This is not scientific research or anything, so it's kind of a ballpark. What about security? Yeah, well, 1. Actually, GitHub, yes, combining 2 jobs. Actually, GitHub, I think 2 years ago said it's not 100 to 1, it's actually 500 to 1. So it's even worse than it is. So and so what security has ended up doing, right? So security just can't keep up with the pace of change. So security ended up clearing all the mess after developers. I have all the credits, by the way, under that. This is not mine. I just found it, and it's funny. Okay, part of the problem is that when developers come to security and they say, okay, we have this new tool, right? Or we have this new plugin, or we want to use something, we want to experiment. What's the typical answer that security gives to them? No. And what about the 10%? Well, it's no in different color. Okay. So, well, the bottom line is that security is known as the department of no, at least in big companies, government. So developers, what do? Like either they give up or they find a way to bypass you, right? Neither is good. So what's the solution? So we want to add security in DevOps because remember, like operations had this problem with developers and they somehow fixed it with DevOps. So security wants to be also part of this. And so that's why we, as industry, came up with DevOps. There is different names. So it's just like another name of the same thing, another name, and so forth. Somehow DevSecOps kind of got stuck with everyone, and that's what everyone is using. So what is DevSecOps? Okay, what is DevSecOps? It's a joke, just like it. So what is DevSecOps? Okay, this is DevSecOps. That's another, and it's not a joke. It's a real, it's a reference, DevSecOps reference architecture from Sonatype, and I believe they keep updating this. So it's actually, if you zoom in, if you have a magnifying glass, then you can see some familiar names, brands. But my point is that it's a lot, right? It's a lot. I like this DevSecOps infinity loop because it really shows you how everything is connected, right? So it's no longer waterfall where you start with planning, you finish with the end product, and you never get back any, you never get any feedback. With DevSecOps, like this, it's a loop, right? So you start planning, and this is where you define your requirements. This is where you, as a developer, you work on your, think about your features you're going to be implementing. As a security, you do threat modeling. As an architect, you define reference architectures. This is all planning. Then code is one, as the name suggests, this is where developers actually write their code. Build is that we build a package, whether it's a container or it's a zip file, whatever it is, that artifact which you're going to be implementing in production. Then you have to test it, then you release it, you deploy it, and then operate and monitor. This is when you have your application already in production and you just monitor that to make sure it's working. So we'll come back to this loop later. So what DevSecOps isn't, it's not creating reports, okay? If you think about, like in old days, you have a project, you did a vulnerability assessment, pen test, whatever it is, and then you just kind of throw it to your project team. In DevSecOps, it doesn't work because it needs to be part of the pipeline. The measure of success in DevOps or DevSecOps is the working application, working software. It's not a report which you did. So you need to work together with developers to get it done. DevSecOps, it's not breaking the builds, right? Sometimes you need to break a build. Let's say if you discover that there is a secret in your source code, like API key, then yes, it's a red flag. You need to do something with that, but you need to be absolutely sure that something is real, true vulnerability before you break a build. And it's not, also you don't want to slow down the build. There is a rule called coffee rule or something. Basically, how long it takes for you to brew a coffee and drink it, 5-7 minutes. That's how long your, like, now I'm going to be talking about CICD pipelines. This is how long it's going to run, right? If your security test, let's say you embed dynamic application test and it takes 8 hours to run, this is not good. So you need to either tweak it so that it's focused on your piece of application, or you need to run it in parallel. Maybe run it overnight and then feed the results back to your pipeline. I like this quote from Accelerate State of DevOps report, which talks about impact on developers. And really, like when we do security right, then actually reduces security risk and then brings developers joy, which is very important. So you want them to be your friends. You don't want to alienate them, right? So they bypass you. Okay. So let's talk about compliance. Question for you: when you hear about compliance, and Gart already talked a little bit about that. When I say compliance and security, is it the same thing to you? No. So yeah, it's not the same thing, and the difference is that I'll give you an example. So let's say you have your static code analysis, and you have the tool set up, then you run it. It discovers maybe some vulnerabilities, you fix it, but the next day you get breached, right? Because there are some vulnerabilities you didn't discover with your static testing. So that's the difference between compliance and security. You might be compliant because you have a tool, you run your tests, you fix your vulnerabilities that the tool found, but you still have some vulnerabilities. So that is the difference between compliance and security. But compliance is it's all about checking the boxes, right? It's about, you have a law, you have policy standard, you have some requirements, procedure, and this is to make sure that you follow that. So sometimes when you are compliant, doesn't mean you are secure. But if you're secure, usually you are compliant. So what we're going to be talking here is how do we build that? How do we use DevSecOps to be secure and also as a side effect become compliant? So you don't want to just focus on compliance without focusing on security. Okay, so that's the definition. We pretty much talked about compliance already, what it is. And so why do we want to become compliant, like from a security perspective? What's driving compliance? Lawyers, okay, yeah. It's actually, legal and contractual obligations, exactly. So someone says, well, you must do that. There is no other way around. And so in the next slide, I'll give some examples of those mandatory security compliance frameworks, requirements. what else? Why do we want to be compliant? Like, what does it give us? Insurance? Yeah, it's a good one. Yeah, insurance. Yeah. It's also building trust and credibility with your customers, maybe with like people or companies, like whatever your target audience is. Maybe you want to enter to a new market, right? And then you want to show them, oh, I have compliance, I have SOC 2 report, right? Which is kind of a ticket, right, for you to book entry into that market. And sometimes you also want to self-improve. You understand that you have some gaps, and why not? Like I can do things here and there. Yeah.
I'd also suggest that if the project or a company doesn't know where to start, it probably gives them a reasonable roadmap on where to start.
Yeah.
Even if, aside from legal or other things, it's really when they're sort of so focused on features and functions that they just don't.
Yeah. For those online or in the room, when your project doesn't know where to start with security, then you want to use compliance framework. So at least it gives you like some guardrails, some compass where to go. Yeah, it's a very good one. And as I promised, some well-known compliance frameworks. So let's start with the mandatory ones. GDPR in Europe, HIPAA, healthcare, right? PCI DSS, SWIFT, CSP, cloud, cybersecurity framework. There is many more. I just listed those that you might have heard. Depending on the industry you operate, you might be subject to one compliance requirement or multiple. Like in financial industry, there's usually many, and then you have one for Canada, then you have one for each province, then you have one for the US, you have one for Europe, and it's kind of it's a profession how to maintain compliance with different regulatory requirements. And then there are some nice to haves. So CIS is a good place to start. ISO 27001, that's it's kind of, well, it's not must, but many companies or many clients actually ask for that. NIST cybersecurity framework is a good one. Cloud Security Alliance has their cloud control matrix, which gives you also very good kind of, yeah, it's a pretty good framework. And there are many more. So what are we concerned, like when we talk about compliance? What are the questions that usually compliance folks raise? And by compliance, by the way, I mean like audit, risk, like they all talk about the same thing. By the way, this is not a real O'Reilly. You can, yeah, I found a tool, you can play with it. You can use the animals and then just write whatever you want. So in case of DevSecOps, right? So can code be deployed to production without formal approvals? Like, can we do that? Like, it's a no in traditional world. Like, you have to have approval for your change. But in DevOps, DevSecOps, it's a possibility. Can developers insert backdoors in production application? Right, that's another concern. Who can make configuration changes to CICD pipelines? Are we able to detect and fix vulnerabilities prior to production deployment? Is our application under attack in production? So those are all good questions, and there is many more questions like that. And so we in security and even over in development, like it's our kind of job to think about controls, implement them, and then also show compliance folks and audit folks that yes, we have them, and here's the evidence. So I think that DevSecOps is the ultimate compliance solution, and it's a really secret weapon, and that's why I call this presentation like that, because it really if like it looks complicated before you start or while you implementing this, but once you've done with your implementation of DevSecOps, it really is easy, because if things are automated, then you can just rely on that automation. So compliance as code is really a big thing right now, and it's a subset of infrastructure as code. You basically just run scripts in your like CICD environment, or you run scripts to query your production systems or your application, which is in production. You name it. Like, you also like work with different scanners, security tools. It's all about code, right? And as for those of you who know about infrastructure as code, like, we used to build servers manually, and not anymore. Like, we actually can, if you want to spin up a new Windows server, then you can just run a PowerShell script or ARM template in Azure, and you can get it done like in seconds. So, and compliance as code is like that. You want to get there. Okay. So now, I'm just gonna check time. So now let's talk about a typical CI/CD pipeline. Okay, so I'll do a little bit of explaining here, and if you have questions, please stop me. I'll explain more. And this is based on GitHub. It doesn't have to be GitHub. It can be GitLab. It can be Jenkins. It can be, you name it. There is many applications, CI/CD tools available, and pretty much many of them have the same features. It just happen to be GitHub. So as a developer, I have my main branch, and this is where main branch is my source code for my application, which I have running in production. This is called main branch. We don't want to touch that for no reason. So when I want to introduce a new feature, then I create a feature branch, and so I do what's called checkout branch. So I get a copy from my main branch and create this feature branch, where as a developer, I'm going to be making some changes. So I'm making changes, developing, and then I want to commit those changes. And so when I'm ready, like after all those commits I made, I want to get my changes back to this main branch. So what do? I don't just copy them to the main branch. Although it's possible if you have privileged access to GitHub or whatever, you don't do that, because it's dangerous and it's against security. So you want to create a pull request, and that pull request is basically my request to merge my code back to the main branch. And pull request usually triggers some checks and balances. And in GitHub, it's called GitHub Actions. It's a set of plugins that you can run, set of tests you can run as well, which do something with your code. Maybe it's a static application test, and maybe it's linting. It's like grammar spell checker for your code. Maybe it's some unit testing you wanna do, like QA people do. So there's many different things that you can do here. And so if I pass, then I go to the next level. If I don't pass, I have to fix whatever error messages I got, and then I start again. So that is really key difference, because we can have security controls right there, and we don't have to wait until a pen test later, which is expensive. It takes time, and it's very costly to fix vulnerabilities. You want to find, if we're talking about security, you want to find those vulnerabilities here. And as a security engineer, I don't even see that. Like, it's all like my developer is interacting with the scanner on their own, and it's completely outside of my view, which is good. So I can focus on my things. So if I pass the test eventually, then someone will have to approve my pull request, hopefully, and then I'm able to merge my changes back to the main branch. This is a cycle, and then upon merging, or push merge, it's really the same thing here. I run another GitHub Actions set of tests, and then once that is successful, then I can finally get my artifact, which can be a container, it can be a package, zip file, whatever you have. So this is called CI, continuous integration. And this allows many developers to work simultaneously on the same project, working on different features. And that's how it's set up in GitHub, usually, and in similar CI tools. So now let's talk about CD. So CI, CD. CD means two things: continuous delivery and continuous deployment. And really, continuous deployment is delivery plus one more step. So when we talk about CD, we usually talk about different environments. And you might have testing environment, you may have user acceptance testing environment, production environment. Different companies call it differently, but this is the idea. You move your code from lower environments to higher environments, and you do testing in each environment. And we also use GitHub Actions in those environments. And so that Docker container we created in the previous step, which is going to implement it in testing environment and see how it's working, right? And run other tests. Then we do the same in UAT, and then eventually we move to prod. So this is what like I said, it's called continuous delivery and continuous deployment. Now, why it's important? Because we want to embed our controls within CI/CD. Okay. I already mentioned a couple of them. So SAST stands for Static Application Security Testing. I'm not going to go into details because it's a separate presentation. And 1 week ago, Magna Logan did a wonderful job on SAST and DAST and SCA. So I'm just going to quickly talk about that. But if you have questions, please ask me. This is what I was talking about, the developer interacting with your tool to make sure that there's no vulnerabilities. You want to implement more tests in a second place where we run GitHub Actions. And you also want to do static, right? But you also want to do what's called software composition analysis. And that is the difference between static application security testing and software composition analysis is that the former focuses on the source code which your developers wrote, and software composition analysis is scanning your code which you didn't write. It's open source. You just borrowed it from someone. And I think statistics says that right now modern applications comprise of 90% of open source code. So it's like 90 to 10. So you only write 10% of your own code, and then you just rely on open source libraries and frameworks, which on itself is a risk. That's why we want to have some scanners which can tell you whether you have bad source code. Do you have bad dependencies? Do you have bad dependencies of dependencies? So things like log4j won't happen, right? Secret scanning, you want to scan for any embedded hard-coded secrets. And then container scan. So just before you build your container, you want to run a container security scan, and by the way, like this is all embedded in your CI/CD pipeline. So once done properly, it requires zero human interaction. So it's just going through the pipeline. It's like a cron job. Think about GitHub Actions as like a job scheduler within your integrated development environment. And then once you get to different testing environment, user acceptance test and production, you also want to run your tests, but those will be slightly different tests. One of them is dynamic application security testing. For you to run DAST, you need to have a running application. So it's not enough just to have a source code. You need to run it somewhere in your container or on your virtual machine. You also want to do vulnerability scanning and harden if you build your virtual machine or container to make sure that you don't break any rules. Okay, and so you see that heading changed. So from security controls in CI/CD to security controls of CI/CD pipeline. And so what that means is that we also want to, and this is what's missing sometimes. We think about all those controls like static, dynamic, software composition analysis, container scanners, etc. You embed them into your pipelines, but then you miss them to secure your own CI/CD environment. But this is equally important, because if that is not secured, then your controls may be circumvented at any time. And so for that, there are some rules that you have to stick with. And by the way, I'm just going to click in the interest of time. I'm just going to talk quickly about that. But I want to emphasize that OWASP actually has a project or deliverable, which is pretty cool. It's called OWASP Top 10 CI/CD Security Risk. So everyone knows about OWASP Top 10 vulnerabilities, right? It's a buzzword. Everyone uses that. But OWASP actually has top 10 other things: API vulnerabilities. They did this one, CICD security risk. And what you can see here on the screen is kind of a summary of that. And really, what this is about is you want to restrict access to your CI/CD pipeline. You don't want to have a wild west where everyone or every developer can do configuration changes. You want to restrict that. You don't want to have any auto approvals. So someone will have to review a pull request. Then you don't want to have any hard-coded secrets. And if you have to use a secret, use OpenID Connect instead. This will allow you to have a connection from your CI/CD environment to a cloud service provider. That's a secure way of doing that. Then you also want to control changes to your workflows. And if you use any third-party workflows, jobs, right, which I was talking about, then you also want to make sure that those sources are reputable and they don't have any vulnerabilities. And last but not least, you want to collect logs. So whatever is happening in your CI/CD environment, you want to collect logs, and you want to send it for analysis to your log collector and your security information and event management system. And just a very quick example, what can go wrong is usually governance, risk, compliance people use it to describe risk. Let's say we're talking about unauthorized changes to production. So how do we prevent that? You can have a control that right people are making changes through. And for that, these are the things that you need to have in place, such as if your developers have access to your development environment, then they want to use a secure connection. They want to use multi-factor authentication. You want to define roles in your CI/CD environment. You also want to do code signing so that we know that it's John Smith who signed that particular piece of code. And you want to have a vault for your secrets. And the second control is about changes. It's all about automation. So is it okay for developers to have access to production environment? No, it's a bad practice. I agree, but sometimes you have it. You have to have it just because developer is the one who can actually fix. If something happens in your production environment, you should be able to fix it quickly. And that's why you need just-in-time access. You give it to, it's a break glass kind of access. You give it to your developer, he or she fixes that, and you revoke that access. Yeah, secure environment and development practices. So this is just an example of compliance requirement and real controls which you can implement in addition to what we were talking about in CI/CD pipelines. So what do we learn today? Compliance is code. That should be the focus. And we should, as security people, we should be thinking about, we should be using the same tools and techniques as developers use, which is CI/CD pipelines. So we want to be doing the same thing as they. Focus on automation. Be careful with breaking or slowing down builds. Otherwise, developers will hate you and they'll find a way around. You have a question?
I agree. What does that mean practically? What do you
Yeah. 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 So I'll repeat the question. Yeah. So what does it mean? Don't break or be careful with break and builds. Like, what is reasonable? Where you should do this, where you should refrain from doing this. I think to answer your question is it depends on maturity level where your particular team or organization at. So if you're just starting with DevOps, DevSecOps, you probably want to be in monitoring mode for quite some time until there is enough expertise, there is enough confidence that your tools that you chose are actually working and they don't just generate lots of false positives. Because the worst thing is that you implement this new shiny tool, right? And it's very noisy. It keeps breaking the build so no one can go through, right? And everyone is hating you for this tool, right? So you don't want that. I guess it's good if you pick the right tool, which is not noisy, but sometimes you have to try different things. So I would just start with monitoring, and then once you're comfortable with what you have, then move to blocking. So you can get from 0 to 100 in just one go. So it's a gradual process.
That's really a change management. That's a culture thing.
It is, yeah.
Don't burn your partners with this.
Yes. Yes, it's a cultural change, exactly. And yeah, you don't want to, throw your developers under the bus because they'll do the same to you, right? And you lose your reputation, and they'll say, well, security, screw it. Okay, good question. Shift security left. So we talked about doing security testing as early as possible, equipping developers with tools that they can run their own testing, right, before it comes to you. So that's what is called shifting security left. Question. Yeah, so the question was about, is there any key metrics that can be used to measure success of DevSecOps? Yes, I think, so there is what's called DORA metrics. I think it's Google, if I'm not mistaken. Basically, yeah, there are some kind of industry best practices you can find. One of them is, just, off the top of my head, is a number of vulnerabilities. No, it's time which takes you to fix a vulnerability. So you want to be reasonable. You don't want to, let's say you find a medium risk vulnerability and you tell developers, oh, go fix it tomorrow, right? It's not reasonable, right? But if you have a critical vulnerability, you want to fix it as soon as possible. So just like your remediation timelines are based on the severity of those vulnerabilities. So that's just one example. But there are others, like how long it takes for you to restore your production environment after a bug, security bug or incident, right? There are some key metrics that, yeah, just Google DORA metrics. Yeah. Yeah. Yeah, so the follow-up question is, okay, yeah, we have those DORA metrics, but it still depends on the company. Like each company is different. I agree. That is probably, well, there is no one size fit all. Like you need to find what works for your company. And again, it's maturity. You start with some basics and then you kind of mature. And maybe those DORA metrics is like level 3 for you, right? And then you start with really basic things like, can I at least detect vulnerabilities? I'm not talking about fixing them like within, I don't know, 30 days, but can I at least detect them? Yeah, it does depend. I agree. Okay. Same old security basics like patching, right? Are we patching our servers? Are we recycling our vulnerable containers on time? Are we following like hardening best practices? Do we run like static application security testing, right? Do we even have the right tool? So this is like all those security basics are important. Like we tend to talk about 0 days and some high rocket science, right? But really it comes down to basics. And I would start with inventory. Like, do I know all my applications? Do I know all my source code repositories? Do I have my scans enabled on those source code repositories? So I think this is really, like, you start with basics. And you also want to keep evidence of what you do, because when audit comes, risk team comes, they want to see, do you have evidence? Because they trust but verify. So it's important that you keep that. And you also interact with developers on their platform of choice. If they use Jira for bug tracking, use Jira. Don't invent something unique, right? Have them, like, you adjust to them. And it's everyone's job to be secure and compliant. And so security this way can become Department of Defense. Thank you so much. And if there is any more questions, please ask me. Do we have time for questions? Yeah.
Well, at least for my question. When we were doing a breakdown, even ones, per se, other than a great class case, developers having access to the actual pipeline mechanics. In your experience, what is really the reality? It's hard to find staff, and so there's a lot of double roles filling multiple roles. So, in your experience, how common is it to be able to have that sort of separation of duties?
Yeah. So the question is about separation of duties. Like if you, let's say, have a smaller squad, development squad, and you really have jacks of all trades and don't really have a luxury to have one person dedicated to each task. How is it in real world? I would say that, like in my experience, you still want to separate normal developers from like team leads, or if you have many development teams, maybe there is like a centralized DevOps engineering team that can hold the keys to the kingdom, and that's the only team that can make configuration changes to your CICD pipelines. But if you don't have that, at least having like team leads be responsible for that extra configuration would help. With compliance, though, it can become tricky, because then you have to answer a question. All right, so I have developers who also have access to my CI/CD pipeline, who can make changes to my control environment, right? So this can become tricky. In this case, you probably may want to take away that access on a day-to-day basis and use like a break-glass process to make those configuration changes. And you don't want to make those changes all the time, right? It's only when it's necessary. And you also make sure that you maintain audit trail, like you have login, you have evidence that supports that what you've done is what you've requested to do. I don't know. Did I answer your question?
Yeah.
Thank you. Yeah, please.
Just following on that, in theory, let's put aside the service area problem. If you have really good detection of unauthorized changes,
so the question is there any good detection techniques or tools, I guess, to detect unauthorized changes to, I'm assuming, CI/CD pipelines?
or that complicated controls for that wide access. Do you think you can ever get to a point where, yeah, it's okay that everybody's
Yeah. Yeah, so when we talk about controls, there's there's two groups of controls, preventative controls and detective controls. So when we talk about preventative controls, we talked about access, right? So can I only grant access on a based on the least privilege principle? Need to know, right? If I can do that, then it's great. If I can't do that, if my team is small and I still have to kind of use the same resources on the team, then you rely on detective controls. And this is how you, on the previous slide, there was audit, the last bullet point. This is like you get that you get those logs from your CI/CD tool and you store it somewhere else, like outside of CI/CD, so that developers cannot make a change and also erase the logs. So you want to kind of ship it outside of your environment, and this way, at least, if something happens, then you have record of that. And yes, like GitHub, for instance, allows like it's very flexible. It has a bunch of events that you can monitor for, and then you get those logs out. Yeah. Any other questions? Yeah.
So early on, we were talking about the disproportion between developers and security.
Yeah.
It happens a lot that there's just too much for the security team to handle. And what do you do when you're seeing that the security team is overwhelmed? Where do you decide what to prioritize?
Yeah, it's a very good question. So security is outnumbered by developers. And so what do you do when your security team is overwhelmed? There is just too much work to do. It's a very good question, and I know it's dear and near to almost everyone's heart, myself included. And one of the techniques you can build automation as much as possible. And DevSecOps really is one of the answers, right? So if you do that, then you just rely on DevSecOps to do all those security checks, hopefully, right? Now, if you still have to do some manual work, then and that work can be done by, you can delegate that work, then you can think about security champions. And so one of the talks, I think last month from Tanya Yanka was about how to build that security champions function. And like we've implemented this in my workplace, we call them risk champions, but it's the same thing. We actually delegated some manual work. They actually go and check reports, like SAST report. They check like a software composition analysis report, and they document this, and then someone from security reviews the result, which takes them 5 minutes as opposed to 5 hours. So this way you can delegate some of the work. You can rely on automation. You can outsource if you can, like if let's say pen test, right? You don't have to do it in-house. You can have someone do a pen test once a year or once a quarter. So there are different ways. It depends on a level of maturity of your company and also level of support. So you want to make sure that your leadership team supports you and understands the risk, and this is your job to explain this, but also that you get that support in return. Yeah.
In the pipeline, there are many scanning, static code, and scanning. So the result of the scanning is usually someone is doing. In real world, how do you how the because you're not going to do every single scanning.
Yeah.
And then when you have a result, you need to either identify it or go back to it, or migrate the knowledge. Okay. So how often do you suggest for practice
Yeah. So the question was, in real world, when you add all those scans, like static scan and dynamic scan and container scan, and how often do you manually review the results, right? So to answer this, if you can build fully automated pipeline, I think that should be your goal. So you want to build all the security controls in your CI/CD pipelines and harden your CI/CD pipeline so that no one can make unauthorized changes, and you just rely on that automation. So that's the ultimate goal. Now, not everything can be done this way. Like pentest, for instance, I don't think you can do Dust, automate Dust, but you don't automate pentest because there is a human being which does exploitation and writes the report. So for that, you want to dedicate your resources to review it every time it happens. So it really depends on the control. And so for every security control you want to embed into your pipeline, think about, can I rely on automation, or do I have to manually verify results? Yeah. Yeah. So yeah, the question is, what if you find a critical vulnerability using one of your scans? What do you do? What do you want to do? Like, do you want to block that build, or you want to let it go? You definitely want to, if it's not false positive, you want to block it, because if it's critical, that means something bad can happen, and you don't want to have that critical bug in production. Yeah, you define a threshold. Yeah. 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 So what if you can't fix everything, and then you have another release coming up, right? So you define a threshold, like a bar, right? And your bar can be, I cannot go with highs and criticals, and I'm okay with lows and mediums, and I'll fix them. I don't just ignore them. I'll fix them within like the next 90 days. So you just define that, and then as you mature, like your bar is going to be lower and lower. Yeah. Yeah, and you also can risk accept. You're right. Yeah, some of the things that you're never gonna fix, and then you just honest with yourself, and someone will accept that. Yeah. And, question.
That's true. And so the question is that in the whole automation pipeline, how can we automate differentiating the false positives from the real vulnerabilities? What I say, usually you have a person, you should try to everything kind of recreate that to see if it's false positive or not.
Yes.
But I don't know if you can put it in the automation.
Yeah, so the question is, how do we deal with false positives? Like, can we automate that triage of false positives? Well, there are ways. Well, you want to pick a tool which doesn't generate a lot of noise, right? Ideally, it should be zero, right? But it's never zero. Maybe it's 10%. So for those 10%, I've heard that. So SamGrep is one of the open source projects of OWASP, I think. They actually just implemented GPT-4, like using AI to help with triaging. So actually, AI can do this analysis for your security folks, and it can say whether something is false positive or not, which can even further reduce number of false positives. And then again, it's your confidence level, right? Where do you start blocking? Like if you're comfortable with your tool, you use GPT-4 to help you, and then maybe instead of 100 vulnerabilities, you get one, and then you pay attention to that, and then you can break a build. Okay. All right.
Small clarification, I don't believe it's SamGrep is the OWASP project, but they listed in their tools section.
Okay, all right. It was, yeah, false advertisement. Yeah, yeah. Okay, thank you very much.
Thank you very much. We're just going to get set up for our next presentation. As this will be, I think, the first time we've done hybrid in the room, we will watch technology live, the demo thing, right? We'll go sacrifice something and maybe the demo will work.
Hey, I can see myself. I'm on TV. But I can't hear anybody else. So if you're introducing me or something like that, I have no way of knowing.
Can you hear me now?
Now I can. Hello.
All right. So you're live. I need to introduce you. So sometimes the best security people are the people who can actually disassemble things. So imagine poor Jared's parents coming home to find their stereo dismantled on their living room floor. And from that, he had the skill to get into software and was a software engineer for 12 plus years. If I'm guessing, remembering reading the details accurately. And then he made the jump 5 years ago into security. People get into security from many different backgrounds, but similar to me, my course was through software development. So we know where things go wrong. We know where the pain points are. We know what has to be done by Friday, no matter what it looks like. We all strive for beautiful code, but, sometimes, all things are beautiful. It's just some things are more beautiful than others. So with that, and with everything being APIs and GraphQL being the new sensation, I'm very interested in understanding how can we test this in a pen test. So I'll shut up now and I'll leave it to Jared. Welcome.
Oh, thank you. Thank you for the stunning introduction. Yeah, software development was my foray, and that's why now I do application security, because the other thing it makes you really good at is after building software for 12 years or even 5 years, is you start to get a sense for where people make mistakes and where you can get in. And GraphQL, I'm going to talk about what it is in a second for those of you who don't even know what GraphQL is. So don't worry, this is aimed at everybody. But one of the interesting things about it is that it's a new thing, newer. It's starting to get implemented into more and more high level applications, like GitHub uses GraphQL, and I think Yahoo was one of the first companies to do it. But there's lots of, if I pulled up the page for GraphQL, there's names that matter. But it's a new thing. And so people don't know how to test it. And so we're going to take a look at what it is, and how we can sort of what's the word I'm looking for? We don't want to be overwhelmed by it and think, oh, it's this brand new thing. It has all the same problems as older stuff. So this is me. I'm a senior AppSec consultant. I work at a company called Forward Security. The company's in Vancouver. I live in Toronto. And so, yeah, all told, I have about 16 years of web API and design and development. So that includes, the years that I had been doing security as well, because I've been doing some development along the way as well. So 5 years in security professionally, but like many of us, before I was a pro and making money doing it, I was, exploring the world of security in, maybe less above board ways. And at this point, I have my OSWE, my Azure Security Engineer certification, and actually one that I haven't added here. I recently got my AWS Security Associate, whatever they call it. But the important one is the OSWE. If anybody's interested in being an AppSec consultant, I highly, highly recommend looking at the OSWE course. It's extremely difficult to pass, but that for me tells me that it's a very valuable piece of paper to have. And when I see this on somebody's resume, it all but guarantees that they're a great candidate. So with that being said, by the way, Forward Security is looking for some AppSec consultants. Okay, so I can't see the audience, but can I hear the audience? Can you point the mic at the audience? Maybe by woos. Has anybody even heard of GraphQL?
Woo it up.
Woo it up. I hear a distant clap. Okay. How many people use Burp Suite?
Show of hands, looks about like 6, 7. What?
Out of how many? 6, 7. Okay.
At least one,
So,
yes.
okay. So has anybody who has heard of GraphQL and used Burp, has anybody actually pen tested GraphQL with or without Burp?
We have 1, 2, and a definite maybe 3-ish.
Okay. And have any of those people tried to use Burp to pen test those things?
There's 1, 2 people.
Okay. Let me tell you something.
But
It's
that
a
was
pain.
very tentative, shy hand.
That's a larger response than I normally get, because most people haven't at all. So that's great. I'm happy to hear it.
We're all in Ottawa, so we're just out of control.
So here's what we're going to do. I'm going to give the intro, which I just did. We're going to talk about what GraphQL is. I'm going to talk about how to attack it. I'm going to talk about what's currently available to attack it, and where Burp fails, and where I fixed it. And then I'm going to show you how to use it, and then you can ask me questions. So what even is GraphQL, right? It's a query language for API. Okay, what does that mean? Everybody's familiar with, or I would think most people, at least people who are doing application security or who are hacking websites, are familiar with REST APIs. So REST API, that's basically making GET requests and POST requests and PUT requests. And, if you're really fancy, delete requests and head requests, things like that. Excuse me. So GraphQL is just another way of doing that. It actually travels along the same pipeline. You make an HTTP request to your server. Usually it's just / GraphQL. You have one endpoint. So this is like the problem that GraphQL solves, is that, there's a few problems that it solves. But one of them is that you don't have to make multiple endpoints. You can have one endpoint. It's the / GraphQL. And then you make your HTTP request to that. Usually they're always POST requests, regardless of what you're trying to do. Whether it's a GET or POST or PUT or any of those types of actions is defined in the JSON body of the request. So if you look at the request, you'll notice that it's not quite JSON. The response is JSON. The request is almost JSON, but it uses indentation. You notice there's not everything has properties and values and quotation marks and colons and things. But that's how the a query looks. It's kind of like a JSON object, and you're kind of making like a query to your backend. It's almost like you're treating your server like it's a database. And then on the back end, you use a library. Actually, let me, I'm looking at the wrong screen here. Let me take a look at my PowerPoint, because then I can take a look ahead and just see if I'm explaining something that's going to be in it already. So no. So in the back end, you're going to use like a library, a GraphQL library, and it does all that heavy lifting for you, right? You you install this npm package or Python, whatever you're using, and then there are some things you have to define, and then boom, you have GraphQL. So the other benefit, the reason why people like this is because not only do you have just one endpoint to maintain, but you can leave it up to the front-end developers. You can have a lot more separation between your front-end and back-end developers. So for a really big team, this is especially useful. So the front-end developers have a lot of freedom. They can make whatever kinds of requests to the back-end they need, and they don't have to say like, oh, for this module, if only we had, the ability to query for such and such. Let me send a ticket to the back-end team and ask them to make an endpoint for me. Well, you don't have to do that with GraphQL. That's the benefit of it. So this is why everybody's excited about it, and has been using it. But it's just as vulnerable as regular REST APIs. Okay, we're going to talk about how we exploit it. Don't worry, we're going to get to the cool, it's the fun stuff, right? In addition to that, it has some bonus denial of service vulnerabilities. I'm not going to dig too much into those because, first of all, denial of service vulnerabilities are kind of warning. And secondly, in the later versions, you're using an up-to-date GraphQL backend, and you haven't.
Jareth?
Can you hear me?
Your audio is starting to sound like Jimi Hendrix.
Oh no!
And it's distorting, which I don't think was.
Is that better? I turned it off and back on.
Yeah. Do the Windows thing. Turn it off and on again.
Okay. Let me switch my.
Oh, and then there's an echo.
Is that better? Can you hear me now?
Oh, that's so much better. Yes, thank you. You weren't disassembling your microphone, were you?
No, not today. If it happens again, I'll just switch back to the other mic. We'll just go.
I'll jump into the screen and.
Okay, thanks. So, denial of service vulnerabilities. The denial of service is a bit boring, so we're not going to get into that. But the other reason is that the bonus denial of service vulnerabilities that GraphQL sort of comes with, when you use the later versions, the more up-to-date versions of the backends, they're usually, unless you've configured away from the default, you're pretty much safe by default. The other thing that's really cool is that it self-documents. So with a REST API, you would need like a Swagger file or an OpenAPI file. If you don't know what that is, it's basically just like, it's a document that lists all of your endpoints, right? And usually you don't make that available to the public. Some people do, some people don't. I'm of the belief personally that if you're hiding that from your users, you're getting into the realm of security by obscurity. And I mean, it's always helpful to not give attackers an extra edge by knowing what's there, but in my opinion, that's not the kind of security you should be after. But GraphQL has a similar mechanism. Instead of having this Swagger file that lists all these endpoints, it has what's called introspection. And it's a special query that you make, and it gives you a list of everything that you can query for. And it exists so that people who are front-end developers can, makes it easy to programmatically query for things. Right? Okay. That's GraphQL. It may become more clear as I go on, but GraphQL basically, it's like a REST API. We're just making requests to the backend. It just looks like a JSON object instead of like /users/get, right, to get a list of users. Instead, you would do, where it says hero, you might say users, and then I want the names and the heights of the users. Right, and that's what it'll return. Okay, so let's move on. Next slide, please. Okay, so I guess I did go over some of this. So in your application, this is how you would install it. You import your GraphQL library, then you define what they call the schema, which is basically what kinds of things people can query for. So you basically, you kind of say like what types of objects there are to query for. Right? It's not a direct path to your database. It's a direct path to your application, and your application defines what kinds of things can be queried for. And then, so if you say like, I want people to search for heroes, like we had in the first slide, then you need a hero object that's registered for GraphQL requests. And then you'll have what's called a resolver, which is like a function that says when somebody queries for heroes, here are the types of things that we can return from the database and do these transformations so that we're doing validation and so forth. Okay, so in replacement for get and post requests, we have queries and mutations. A query is a get request, essentially. Now remember, all of this actually happens over HTTP post request, but in the semantics of HTTP, in the semantics of REST API, a query is you're trying to fetch data, and a mutation is you're trying to change data. And a subscription is something totally different. It's similar to a mutation. We don't need to, it's not important for you to know what it is, but it's just another request type. It doesn't add anything to your ability to hack it, so we're not going to get into it. But yeah, anyways. Introspection. Over here we have the master of introspection. This is Sigmund Freud. And introspection, like I said, this is that Swagger file sort of documented list of every endpoint, right? So in the GraphQL language, that means, in the world of GraphQL, that means these are the types of data that I will allow you to return and to modify. So an introspection query, it's a special query. It's just, you can Google it. It's just a big string that you send. It looks like a regular GraphQL query, but it's got a whole bunch of special characters and special keywords in it. You send that to the backend, and it returns back this master list of everything that you can update. It's useful for the front end. Does it have any? Is it a vulnerability? Is it a vulnerability? This is a good question. Again, I'm of the camp where it's not a vulnerability to have it exposed. Having it exposed is useful for the front end, and if your security is comprised mainly of hiding endpoints and what's queryable, you've got bigger problems, right? You should be doing more authorization checks, more authentication checks. That's how you should be securing your backend, not preventing people from viewing it. But other security people may disagree with me on that, and I have in fact been in many conversations like that. So here's the problem I'm trying to solve. This is Burp. Okay, Burp logs REST APIs. It knows how to eat them. It uses its active scanner. Let me just do another little poll. How many people are familiar with what the active scanner is? And yeah, Garth, if you want, you can just message me in the chat if you don't want to do the whole adding yourself to the. Give me a rough percentage. How many people know about the active scanner or what it's for?
Sorry about that. We're still faffing around with technology here. Can you hear me now? So the first question was, who knows the Burp app's active scanner? And I think we had 4 or 5. Yeah. 4 or 5.
Okay, so let me just, I'm going to start real basic for a second. So Burp, for those of you who don't know, it sounds like there may be a few people who don't know. Burp is a tool that's used by pen testers specifically for web applications. And what it does is you have your browser and you have the front end and you have the back end, right? Of the whatever you're trying to hack. Let's say GitHub, we're trying to hack GitHub because they use GraphQL. It doesn't just work for, it works for REST APIs, it works for anything. But let's say, so I have in my browser GitHub, and I make I do something on the website, and it sends a request to the server, and the response comes back to my browser. Well, Burp sits in the middle there. I tell it to sit in the middle, and it proxies the request from the browser to the server. And what the magic there is that I can send a request. I can have it pause in Burp, so that request hasn't actually made it yet to GitHub. And then I can modify the request or try different things, mutate it, look at the response. It allows you to do all sorts of things, modifying requests. It's a great hacking tool, right? And when you get the pro version, it has this thing called the active scanner, which is an extra cool feature. In my mind, one of the best parts about using Burp. And what it will do is it will automate hacking a website. Well, it'll automate sending known huge lists of known payloads that you would try. It will do those automatically. So for instance, Burp's active scanner, it's kind of smart enough to, it'll look at a request and it'll put in wherever there's input, it sort of knows where input goes. It recognizes a JSON object, it recognizes post data, headers, and what it'll do is start injecting things into those places that are like, let's say, a SQL injection payload or an XSS payload, things like that. And it will do, it's got a huge array of all these different kinds of security things to look for. And it'll send those requests to the server. So let's say I make one request proxied through the active scanner, through Burp's active scanner. and by one request, I mean like I change my username on GitHub or my first name or something, right? So just like a user profile update. The active scanner will take that and make like 10,000 requests based on that. It'll try every permutation of every payload that it has, and you can refine it and tell it, which, let's say I know GitHub is using MySQL and not MS SQL, so I can remove the MS SQL payloads, and it shortens the amount of time it takes and how many payloads it runs. But anyways, the point is, all that kind of stuff that I would do manually, looking for those kinds of vulnerabilities, it does automatically. It's a huge time saver. Really looking just for low-hanging fruit. And then at the end of the day, even still, it will take a guess as to whether or not something is vulnerable, and you actually have to look through the results. A lot of the times it gets it wrong, but when it gets it right, it saves you a huge amount of time. But the thing is, the active scanner does not know how to talk to GraphQL, okay? Before I even move on to the next slide, it doesn't know how to talk to GraphQL. It's because GraphQL is relatively new, so it hasn't been baked into Burp. There are plugins, but the plugins don't do what I want to do, which is find a GraphQL endpoint and send it to the active scanner. There's only one endpoint /GraphQL, right? That's one of the beauties of GraphQL is you've got the one endpoint. What I wanted to do was take GraphQL introspection query, get back the result of everything that I can query for, and then just have the active scanner go at it. But it doesn't know how to do that. So let's talk about safe injection sites. These are places where Burp knows to inject its payloads. Okay. So where do we inject? There's parameters. We didn't see it in the first slide, but here's an example of where you might see a parameter. So on the left side, we've got the request, and on the right side, we've got the response. And in this request, you see, before we were querying for hero, but here we're querying for human, but not just any human. We want the human whose ID equals 1,000, right? And then we want to get from that human, we want to get their name and their height in feet. Okay, this is another input here. Now you notice this is in quotation marks. This is not in quotation marks. That's because this bottom one is an enum. For those of you who aren't developers, an enum, it's like a constant. It's something that there's going to be an allow list of possible things that you can put in there: foot, inch, meter, something like that. And anything else is not going to work. But the string, now for those of us who are pen testers, we look at that and we go, "That's input, baby." That's not a constant. That's going to be something that hopefully for us doesn't have any input validation. Hopefully, for them it does. So what we're going to do is we're going to tell Burp, find the injection sites, okay, and put your payloads in there. This is an example of a SQL injection that also has like a local SSRF thing in it. And so what we would do is instead of 1,000, we put this big payload in here. And then this goes to the database and goes, give me back the human whose ID is union, also like load file, etc password, and then it returns the contents of the etc password file. That's what we're hoping for. Yeah. So this is how GraphQL wants to be seen, but in actuality, when you send it in the actual HTTP body, it looks more like this. This is actually like, it says, you've got your HTTP post and then your headers, and then beneath that you have this JSON object. There's actually a true JSON object that gets sent, and the query. So right now we're doing a query because we're trying to get data about human number 1,000. So you have. Do I have a beautified version of this? I don't. Okay. Well, it's always sent in this mangled format anyways. But this is, if I beautified this, you would see this looks like a nice JSON object where there's one property. This property is the query property, and the value is this whole thing that is the GraphQL request, the GraphQL query part of the query. The word query gets used a lot here. But that's how it is reading their documentation too. It's just as confusing as listening to me say the sentence. The query property holds the query, which starts with the keyword query, and then contains the query afterwards. And this, you see all these like /n/t. This is all that like indenting that you see here. And I swear to you, it actually contains those new line characters because it needs that indentation in the back end. You know, not how I would have done it, but hey, it works, right? Maybe they know better than me. Right, but then you send this request. So I'm on the website that, let's say I'm on GitHub and I make this request, this GraphQL request. This is what the request looks like in the back end. You know, when you look at when you open the console in your browser, or if you're looking in Burp and you look at the request, it looks like this thing is actual request body, right? And now I send that to the active scanner, and Burp is like, oh, I know. This is a JSON object. No, sorry, this isn't even a JSON object. This is just a string. So what I'm going to do to test is, here's what we're going to do to test for SQL injection. We're going to start with a single quote at the very end of this string, and then put in some, you know, SQL query data, and then close it and put a comment. But Burp, this is not an injection point. This is not how we want it to look. We would want this query, we would want this injection stuff to go here where it says true, because that is where the input goes, right? So I think the next slide clarifies that a little bit. It doesn't. Great. Good job, me, previously making this slide. So if you can imagine, the reason why this is happening, just to go back, I just want to be really clear about this, is that this whole query, so, okay, let me return back to here. So remember, this is a JSON object, right? And this is actually what gets in. Now, Burp knows about JSON objects. It knows how to deal with JSON, but it doesn't understand that inside that this value is itself a special type of query, a GraphQL query, right? It just sees it as a string. And in that, the way that it tests for SQL injection is it will put a single quote at the end of a string. So it thinks, okay, I'm going to put my payload here, right? And that's why we were seeing this. This is the beautified version of a different GraphQL query. This is for querying for pastes. This is for like paste bin. Okay. We want all public paste bin. We want all public pastes that you know, have this, and return to me the ID, the title, the content of the bullet. And then it thinks it's a string and it puts its payload at the very end. When really, this is the variable input right here. This is where user input goes, right? We've got our property public and our value true. You notice that this is not a string. This would be a better example if this were a string. But that's where it would go, right? This is where Burp should be putting this whole thing between single quotes and double dash, because this is a SQL injection test. So what we want to do is we want to gently coach Burp without being condescending. We want to be kind, massage this knowledge into it. So what did I want to do? I wanted to get an extension. So like I said, Burp is extendable. You can build plugins. They call them extensions, right? I wanted to build a Burp extension that will do that introspection, find every possible request I can make, and then send that to the active scanner and have the active scanner actually know what to do with that, right? Because the whole idea is I want to be able to make the interest. Here's my end game. There's a website with GraphQL. I want to be able to tell Burp what the GraphQL URL is. So it's like https://github.com/GraphQL, right? Normally the GraphQL endpoint is /GraphQL. I want to give that to Burp and then say, go. And it does the introspection query. It finds out everything that it could possibly query for or change, and then send that to Active Scanner. And the Active Scanner sends its hundreds of thousands of requests. And then I go get a coffee, and I come back, and I've got a report to write with vulnerabilities, right? That's my goal. And this is what I've achieved. This is what we've done with this plugin that I've called the Auto GQL or Auto GraphQL Scanner. Okay. So I want you to. I can't see my. I'm going to go back to my. This is when I had microphone issues before, but let me tempt fate again. Go back to PowerPoint. Yeah. So I'm going to zoom in on this next slide here. Phew. This is when I started getting fancy with PowerPoint. So what you'll notice here is that this is the JSON object that we're sending to the server, okay? The properties query. And then inside the value, we have a query who is followed by the query. And what you'll notice is that we have an argument and a value. And look at this. We have this whole like ampersand echo, blah, blah, blah. This is the stuff in red, like with a red background. That is a payload. Originally, the only data that I sent was code asterisk, right? That was the request that I sent to the backend. Everything else between the quotation marks and after that point is a Burp payload where it's trying, here it's, for instance, trying to do a remote code execution like, shell command. That's what it's testing for in this instance. But my plugin, this is the success story, right? You can see that it's actually found the proper place to do it. It's put it after the content that I'm sending, but it's still between the quotation marks. Here's that other quotation mark. It just has it's escaped because it's inside of a JSON value. It's hard to sort of visually parse, but you get the idea, I think. And we got time for questions where we can go over this later. So auto GQL, I want to give it a URL. Optionally customize headers, like maybe I need to give it authorization headers or cookies or something. And then click go, right? That's what I want. It will run the introspection query. It'll determine every possible request. It will find insertion and injection points. That's the important part that this plugin does. And then sends them all to the active scanner. And then you profit. So let me show you this thing in action. First off, we, oh, goodness gracious. Okay, so first off, we have, I want to show you the application that I'm going to be testing against. Okay, it's this. So this is this is like a, some of you may have heard of the damn vulnerable web application. There's a lot of these like damn vulnerable blankety blank. And they're for testing, right? They're intentionally vulnerable apps. This one you can see is running on localhost. It's a Docker container. You can download it and try it yourself. I didn't make this. It's a GraphQL application. It has a back end. We're looking at the front end right now. All runs in that Docker. And I get to test against it. So I can test my tool against it, and it will try to find injection points and vulnerabilities. So this particular application is built to be like pastebin. So you can look at public paste. You can paste privately. There's none in here, but I can create a paste. All right. Hello. And we'll submit that. And now if I go back to private paste, oh, I guess I'm not signed in. That's what, oh, if there was, okay. Apparently there's some cross-site scripting from the last time I tested this. So it would appear in private paste. Now let's go back to public paste, and here's what I had just submitted. Anyways, it's a paste bin. So this is the app that we're going to be trying to attack. Now let's go back. Let's go to Burp. So here in Burp, I'm just going to close this here. So this is what Burp Suite looks like for those of you who haven't seen it. Don't be overwhelmed. It's very simple. It can do a lot, but the basics of it are very simple. You define a scope so that when you test something, and every website uses third-party stuff, you don't want to be accidentally testing those things because they're out of scope, and it's you might get a slap on the wrist. So you can tell it a scope. I only wanted to look for things in this local host, right? I'm pretty sure this Docker file pulls down like jQuery or something. And once jQuery gets pulled into Burp, Burp goes, oh, I can try to hack this, sure. And then it sends it to the active scanner, and it sends hundreds of thousands of payloads to jQuery.com. You go, no, don't, please. They're going to send me an angry letter. So you can define a scope here, just tell it what exactly you want it to look for. Here's the proxy part. So you can tell it to open its own special browser, and you go to the pastebin website or whatever you're hacking. And then as long as intercept is on, when you make a request, you come back to this screen and you'll see the request on the left, and it'll wait for you to make a response. It has paused the request, and you can edit it and do all sorts of cool stuff. But then the other part of Burp, which is very cool, is the active scanner, right? So the way that we do this is there's a passive scanner which comes with the free version, and it looks for things that it doesn't have to send payloads for. So like if you're missing secure headers, like the content security policy header is something you might know if you do web application security. anything that it can find passively, like not by sending anything, but seeing what you have sent, and it just reads the responses. That comes with the free version. But the pro version comes with this active scan, which is where it will see your request and actually send SQL injection payloads and remote code execution payloads and deserialization and whatever else, right? And you access those by going, it's a new live task. I usually just do the predefined one, and I go actively scan all in-scope traffic through the proxy. So that means so in the proxy, I open up my browser, it's proxying through Burp. Anything, any request that I navigate to or click on, any request is going through the proxy and is then going to get sent to the active scanner to have the active scanner find all the injection sites and put payloads in it and look for the responses and whatnot. Okay. Setting up this and making it optimized is sort of outside the scope of this talk, but that's the active scanner in a nutshell. So my plugin, so that's Burp. My plugin is this AutoGQL thing, okay? And here it asks for a GraphQL endpoint. So I'm going to put in, I happen to know for, actually, I can show you very quickly. I do this. I'm going to keep intercept on. Let's open the browser. Just give you a real thorough. Okay, so here, let's go to that paste bin, the damn vulnerable GraphQL app. We've got intercept on, so let's just turn that off for a second. Okay, we've got private paste, we've got public paste. So now what I'm going to do, now I'm going to turn it back on, and I'm going to try to go to public pastes. And so you can see I'm getting, I'm just trying to get HTML here. It's not a GraphQL request yet, so let's forward this one. And now it's making its post request. Now it's trying to get, pastes. Here's a request, okay? And we see that it's going to the /GraphQL endpoint. Okay, so I'm just gonna, let's forward this, and it just turned intercept off. We don't need that anymore. But that's how I know that we access this using /GraphQL. So here's my address with /GraphQL in it. If I'm logged in and I have cookies or authorization headers, I can put that stuff here. You can take it out. You know, this is just if you need to send custom headers. By the way, there is actually another branch of this that's not published yet, will be soon, where it has even more optional customizations, but at the end of the day, they're all optional. All you really have to do is put in the GraphQL endpoint, hit fetch queries, wait a couple seconds, and we get every single possible query, subscription, and mutation that is available on this paste bin, okay? And I'm just gonna, let's go into Logger++ for a second so you can actually see what happened. Here is the request that we just sent, okay? This is that introspection query. As you can see, it's just a regular, it just looks like a GraphQL query, but it has all sorts of random crap in it. This, you can search Google and get this string. It's a general, it's an introspection query. It's a thing you can find, right? Now, the next step of this is, so I've now got all the possible queries and mutations. You'll notice that some of these are checked and some of them are not checked. The ones that are checked have potential user input. So if I let's take a look at this one. So this one that has a check mark on it, this is the login endpoint. You can see that here, I wish I have an extension that allows me to make it look a bit nicer. Give me 1 second while I enable that. GraphQL Rater, it's a pretty good one. These are, by the way, these were excellent plugins that helped me in my research and building. GraphQL Rater was one, and another plugin was InQL. And I'll show you. InQL is really great because it can do a couple things that my extension can't. And it also can do introspections, which is really handy. But here we're just going to use it for, just to make it look nice. Does the InQL one look nicer? No, they're the same. So here in the mutation, this just takes this like really messy looking JSON object and makes it look nice, okay? So again, like inside of this query, we have this mutation stuff, okay? And here, but by the way, I hope this is big enough for everyone to see. Maybe I can. I don't know if this helps at all. I don't know. I actually don't know what you can see, what you can't see. So I'm just gonna, okay, so in here, can I just make this, is there a way for me to just do this? No, okay. So this is a mutation query. You see,
it was great.
It's great. Is it great now, or should I zoom in again?
Zooming would be good.
Okay. Is that better?
I can see it, but I've had my eyes operated on.
Okay.
Everybody
I'll go
else?
deeper.
People with glasses?
Well, luckily
In the
these slides
back
will
with
be
the
available.
telescope. Oh, okay. You're good.
Okay, thank you. So this is a login query, right? So we're going to log in. We want to log in, and for the password, we're going to send this code star. By the way, this is just some boilerplate default stuff that I have built into my plugin. But this is where the input would go. This is where you put your password, and this is where you will put your username. Right? So this has injection points, right? If we go to one that is unchecked, you'll see that this does have an injection point, in fact, but it's an integer. And integer injection points, I sort of decide, I mean, you can still turn it on. You can still click the check mark and it'll try. But I've turned them off by default because they tend to be, even in REST APIs, integers tend to be, and this is a type check integer because there's no quotation mark. So here where it's actually type checked, even on a node backend, unless it's a string, you're very unlikely to find some kind of input validation there. So it's really wherever there's string input, it's going to call that an injection point. Okay, so let me zoom back in. And now the next step is I'm going to hit run scan. But before I do, let me just show you what's going on in the dashboard. I've got these passive scanners going on. These are always turned on by default when you start a Burp session. All this stuff here, these are things that Burp found when I ran this demo previously, but this would also normally be blank. So now let's do run scan. Okay. So let's go back over to the dashboard. One thing I need to build into this is some kind of indication to be like, yep, scan is running, but it is running. We can see here's a new item here, extension-driven active audit. And you can see it's already begun making requests. So we're at 160, 170, 100, 200 requests. Now, this is actually pretty slow. I think it's because the back end, the front end, and Burp are all running on my computer. This actually runs much faster, even if it's over a network, just the fact that the back end is on somewhere else, I think. For whatever reason, but at this point, like, what are we, 20 seconds in? If this was a, some client that I was working on, I'd normally be at like 8,000 requests by now. So it's about 10x slower or 20x slower here. But we've begun, right? So if I open up this window, it'll start showing me all the things it's looking for. These are all the different, there are 13 requests that were sent to the active scanner. And if we go over here, we'll see that there are 13 items that had checkboxes next to them. Okay. Here we are, here's a list of issues that it's found. Now, again, it's found all these not in the past few seconds, but because it remembers its history, it's found these in previous attempts. We can also see what it's trying at any given time. So let me see, can I do this? Yeah, okay, so now we're on. So here you can see it's tried to look for paste with the title, this thing, which is, this looks like some kind of maybe template injection or something like that it's trying here. And we can see the associated result, right? And Burp is pretty smart. Burp doesn't just send these, it also kind of knows, it can look at a response and kind of gauge whether or not there was something usable there, usable as a hacker.
Can you zoom on the request and the response?
Yes, good question. Good request. So where did it inject it? This one, I can't see. This one? This one? Okay, so here it's doing a mutation. It's trying to create a user. And, let me put in GraphQL view mode. So it's trying to create a user, and the user data, there's another sub field in here. We want the password, and the password, remember, code star is all that I provided, and then Burp goes and looks at this other stuff and adds its own payloads here. So here it's adding the payload of ampersand echo blah, blah, blah. It's looking for some kind of remote code execution or shell command, which it will find because that does exist. And actually, if we look at the response here, you notice that we're getting a database error. And so Burp is smart enough to go, oh, we put in some random stuff and we got a database error. That's a pretty good sign that something funky is going on in the back end. And so it'll try this same endpoint again, and it'll probably try it with a SQL injection, stuff like that. Right? The active scanner is very smart. Now, again, I'm going to reiterate this because I've gotten this question a lot in the times that I've been giving this talk. The active scanner is built into Burp. The only thing that my plugin does is it works with GraphQL now. Previously, if I had sent this request to Burp, it would not have known where to put its list of payloads. But now it does because of this extension. So this extension will, first of all, find every possible, let's say endpoint, every possible type of GraphQL mutation or query you can make, and it will tell Burp where to try to put its payloads and send that to the active scanner. Okay. Okay, so that's going. Now, I just want to show you some of the stuff that it's found, which is very cool. OS command injection. So here it's saying the dark red means that it's very confident. And it gives some information here about how it found it. Here's the first request. It does this NS lookup thing, and it has this this domain that it tries to visit. Oops. It's doing a mutation where it's injected into this path part. Here's code star, right? So this is the end of my input and the beginning of the payload. It's trying NS lookup, and it's trying this. See this crazy string of characters here? This is, you see how it goes, .ostify.com. This is another Burp built-in thing called a collaborator, where it'll make a random domain for you that you can send to to test for SSRFs. And then it'll wait for the response and see if any DNS tried to hit it or whatever. So right now, it's injected this NS lookup thing. Now let's take a look at the response. So the response, we got this whole server address, none of this should be there because all it was asking for is, all we're trying to do is import a paste, and we're giving it a path to a text file. And we put in all this NS lookup stuff, which is a network request type of thing. And in the response, we see the response to a network lookup. So we can tell something funky is going on here, right? And the collaborator, again, collaborator is that Burp tool where this giant wxxy blah, 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 .ostify.com, this is a domain this is one of those Burp collaborator domains. So if anything tries to make a request to that domain, which is unique to our Burp instance and our request, Burp is going to go, oh, something actually tried to ping this or make a DNS request to it or whatever. So here's the collaborator DNS query. I mean, it doesn't look like much, but basically this does mean it says the collaborator server received a DNS lookup for this thing that we sent. So that's a pretty good indication that there's a command injection here. So let's see, what did it try next? The next thing it tried to do is echo some random string, right? Okay, so let's see what was in the response to this. The response was that it echoed that exact thing, right? So now we're like, okay, for sure we've got a command injection here. What did it try in request number 3? Sorry, it's a bit hard to center this. Okay, now it's trying to ping. Looks like localhost. I'm not sure what would be the use out of this. Maybe it's just pinging something internally. I do know what the use for this would be, because if you have RCE, one of the things you want to do is map the internal network, so you make local calls that would be local to the internal network, right? And okay, I guess there were no results of this. But anyways, the point being that we found an OS command injection. So the cool thing about Burp here is I can now take this request and I can right-click and do send to repeater. The repeater allows me to take a request that I find interesting and do something with it. So now, let's look at the GraphQL version of that, just so it looks a bit nicer. Now, instead of echoing something, what if I was let's try ls, or maybe pwd here. Okay, let's try pwd. By the way, here's the response window, blank right now. So let's send this. Okay, wait for the response, wait for the response. Might take a long time because we're running that active scan in the background. There we go. And boom, /op/dvga. So we have command injection, and it was found using this this method and the plugin, right? So I don't want to hold you guys on here for too long, but that's pretty cool, I think. It's saved me, because normally testing GraphQL by hand takes ages. And so this adds the ability to leverage the active scanner against GraphQL endpoints, which we were not previously able to do. Okay, so AutoGQL, you give it a URL, customize headers if you want, click go, it does all that fancy stuff, and you walk away, you come back, it's found some things. Amazing, right? Okay. Runs the introspection query, builds a request. I guess this is in here in case I didn't have time for a demo. Run scan, yep. And okay. So here were my stated goals. I wanted to make a Burp extension. I wanted to auto-find every possible request, and I wanted it to leverage the active scanner, and I did all three. Okay. Now here's some key takeaways. We're at the end now. GraphQL is new, and security is often lacking in new stuff, right? But what's really important here is that even though GraphQL is new, it still has the same vulnerabilities as every other previous web application, right? The only thing that's new about it is the format, the way that you type out the request. But it still has to take input at some point from a user, and that user input is still where your vulnerabilities are going to be. Now, GraphQL by itself doesn't really have any inherent vulnerabilities, but most people don't know where to even start looking for vulnerabilities because they go, whoa, this request looks funky and I don't understand it. So I hope you've taken away from this, like how to look at a GraphQL request and where to find input, and to know to look for string input and to try your payloads there. And then number two, to download this from our Git repository and install it into Burp and test it out so you can try the active scanner. Now you do need the pro license to use the active scanner. It's not very expensive. And if you're working for a security company, normally they will have that for you. And if not, ask. This is like one of the best tools you can have in web application security, right? Saves you massive amounts of time. What does it do? It extends the active scanner to find GraphQL insertion points. And it automatically grabs all possible requests. Okay, the other thing I wanted to say is that at certain points during this, I've used insertion and injection interchangeably. They mean the same thing. It's just like Burp uses, I think, insertion points in their documentation, but I think most people refer to them as injection points. Anyways, and that's it, okay? Please, I'm really happy to take questions. If we don't have time for questions now, I don't know. If we do, I'm happy to answer. I can stick around for as long as you want and answer questions. But I'm happy to reach out to me on LinkedIn. That's a good way to reach me. Email, this is my work email, but you can definitely reach me there. Twitter, I'm not as good at responding on there, but every so often I go and check. I'm not a big Twitter file, but that's nonetheless, that's me. You can download it at this GitHub link. And my company's Twitter is /sec if you want to contact the company directly. As I stated at the very beginning, if any of you are looking for work, if you're looking for application security work, even full stack development work, we're looking for both those jobs. Now, if you've never done application security before, but you have a hefty development background, I can work with that. I can train you to be a good pen tester, but I can't train you to be a good AppSec pen tester if you've never done development work before. Because really at the end of the day, it's like knowing how an application works is like, more than half of it. And then beyond that, it's, what are the types of vulnerabilities that we can teach really quickly. That's the easy stuff, right? So anyways, that's it for my time. Do I have time for questions?
Thank you very much. And are there any questions? First question.
And also, I don't know if you're watching the chat in YouTube. I'm not. So if people are asking questions there, let me know.
Yeah, we're watching the chat. We watch everything.
Oh.
Don't mind us. We're just watching your every move.
So hi, first of all, thank you for your presentation.
Oh, you're very welcome.
So I have two questions.
Mhm.
So the first one is that when we are sending the request, like the mutated request,
Mhm.
for example, consider the login web page. How this, Burps will understand if that vulnerability is exploited or not, or that request is successful or not. For example, for
Yeah.
logging in SQL injection, does
Mhm.
it check if the system showing an error message or
Yes.
just another report?
I mean, it's not artificial intelligence, so it uses tokens to look for things. Like it looks for certain keywords. It's kind of dumb. It's a really powerful tool, but it really, at the end of the day, it's just a bunch of if statements, right? It's like you send a request to this login form, and it knows whether or not it's tried a SQL injection payload, and then it looks at the response, and if it sees a SQL error in the response, the next thing it will do is send another SQL injection payload that shouldn't throw an error, like a payload that like closes the quotation marks properly and has a well-formed query. And then it'll look at that response and go, oh, this response didn't have an error in it. And then it's like, okay, there's a high probability here that this is a SQL injection. So that's how the active scanner kind of works. So it's taking an educated guess as to whether or not it's found something. You still do have to go through the list and verify all the findings that it thinks it's found.
Oh, okay. So it means that is still vulnerable to false positives.
Oh, definitely, yeah.
For example, I had this case that the website was really smart. Instead of showing error messages, was showing pop-up messages.
Oh.
And then I was like, okay, so this is a case that we should take into consideration. But I was wondering if we can, perhaps we will also fall for this.
I don't know. That's a good question. So another thing it'll do is it'll just look for anomalies. And in fact, there's a special extension I started using. Shoot, I forget the name of it. But it adds this extra additional feature where it doesn't just look for, like using the login example, it doesn't just look for SQL injection error message. It'll send 2 different requests, expecting 2 different results. And if it gets 2 different results, then that's an anomaly, and that's enough to flag it. So it's a little bit more heuristic. It's not just looking at, is there a SQL injection or SQL message, error message? So that's a good question. Yeah, I don't know. I think you can also, it's highly configurable. Like there's a million options. You can probably tell it what kinds of things to look for. If you know what the error message is going to look like, you can tell it this is a normal error message, and then it'll only flag things where there's an irregular error message.
Okay.
Stuff like that. But for sure, there will be false positives.
Another question?
Yeah.
It's kind of related to the same topic. So basically, I don't know enough about GraphQL, but I would assume that the errors you're getting with GraphQL requests are slightly different than standard REST request errors, right?
Mm-hmm. Yeah,
and
that's true. Yeah.
It's more tailored to standard REST request errors.
So the interesting thing about that is that I didn't actually have to add any additional features for it to understand the responses. And I think it's because it's smart enough to just look at the whole block of text in the response and look for the word SQL and error. It doesn't need to know the format of the response. It just looks for those words next to each other. So like I can get back HTML, I can get back JSON, I can get back XML, and the response, the thing that looks at the response almost doesn't care about that. It's just looking at it as a block of text. The request does matter what format it's in because it needs to know where to put the payloads. But when you're reading the response and looking for error messages, it kind of doesn't matter as much. You can just look at it as a blob of text.
And it's a GraphQL request because you look at the HTTP endpoint, right?
Yeah.
Because it contains GraphQL somewhere in the...
So 2 things you look for. Number 1 is the URL. Usually, not always, will have /GraphQL. But the biggest giveaway is that the actual request itself, if you put it into Burp and you intercept the request, or if you go into your browser and you hit F12, or you get the inspection.
Starts with curly bracket query.
Yeah, it looks like a JSON. It's a JSON object, and one of the values will be query or mutation or subscription, and then the value of that will look like a weird JSON object itself, but like without quotation marks. It'll have like \n/\t.
All right,
That's how
thanks.
you can identify. Yeah. And the GraphQL website, by the way, is also, they really want people to use it. So right at the homepage, it's like teaching you the basics of it. So they really make it easy to understand. I recommend checking that out.
Any other questions?
So what I understand from the entire extension, the process is something like you're using this extension to basically recognize text recognition, like pattern recognition of the specific request, and then you're adding a specific line called code star, and then that is sort of integrated with the Burp's active scanner, and whatever the payloads are the payloads going in there are basically from the active scanner and not from your extension.
That's right. Yeah.
So the main thing that you're doing is basically recognizing if it's a GraphQL query.
Yeah.
The one thing that I didn't understand was how did you inventory the GraphQL queries in the extension?
Okay, so that's the introspection query. So there's that special query that you can send. I was saying you can Google for it. It's just, it's the same query will work on every GraphQL website, any endpoint. If they're using GraphQL, you send this introspection query, and it will give you back the result. In fact, let me show you what that looks like. I think I showed an example of the query itself, but not of the response. So so here is our introspection query. And I'm just going to dive into that. So you see it's a JSON object that starts with query, and then here's that massive GraphQL object. And we're going to do an introspection query. And to do that, you're asking for the schema and the query type and mutations and the names and like you're asking for a bunch of different things. I literally just copied and pasted this from, I think, the GraphQL website because it's the same string and it works everywhere. And then the response looks something like this. We get our data object, which is what has everything in it. This is a proper JSON object. And we have, and here, this is a massive list, but, for instance, we can, here's some types of things we can query for.
So this basically downloads the entire schema, right?
It downloads the entire schema, exactly. Okay. Yeah, that's exactly right.
Okay.
Yeah.
Thanks.
Yeah, you're very welcome. Downloads the entire schema. It parses the entire schema and looks and basically builds a list of all the different types of things that it can query for, and then builds those queries, and then finds the injection points, and then tells the active scanner, here's a list of things to scan, and here's the places where you can put your payloads. Here's where you can stick it.
Any other questions? I have two.
Please.
When's it going to be in the B App Store?
Great question. So I'm working with Burp right now. They've got a really long backlog, apparently. And in our last email, they said that they found a bug that I was not able to reproduce. So we're at a bit of a standstill right now, but hopefully soon. Like soon is a generous word. Let's say by the end of the summer. That's my plan.
Right. Yeah.
But in the meantime, you can manually install it from
lazy.
GitHub. Yeah.
The second question is you mentioned the thing that you are looking to hire. Do you take interns?
We do. We have a mentorship program. So
remote interns?
Yeah, everybody's remote, right? I mean, it's definitely better if you are, in like close to southwestern Ontario, so like Ottawa's fine. But we're not looking for, if you're out in Yellowknife, it might be a problem because then if we ever do want to have a meetup or something, that might be tough.
Right,
but yeah, close to the Vancouver area, close to the GTA, including Ottawa, I would stretch it as far as.
So you heard it here first. Somebody in Toronto accepts Ottawa.
I love Ottawa. Oh my God. I love going there. I've got lots of family there. But yeah, I mean, we take interns. We have had co-ops in the past. I'm probably the wrong guy to ask you about that. I don't know what currently we're looking for, but I know that we do what's called a mentorship program. So if you come on and you feel like maybe you're just out of school, you have some knowledge, but you feel like maybe you feel a bit of imposter syndrome, like maybe I'm not good enough to apply. please, like, let's find out. Let us be the judge. We won't hire you if you're not good enough. But you might be good enough. Let us figure that out. And, you know, we're very polite, very nice people. And also we have these kinds of programs where we have had cases where somebody was, you know, in the interview, they maybe didn't know enough to be a full application security consultant, which is what I am. But, you know, you could see the promise was there. And so we start like a sort of a mentorship where we would teach you and get you up to a place where you can do that kind of a thing.
Awesome.
I mean, personally, this is why I do talks like this, because you know, obviously I love showing off the stuff that I built, but also I really love teaching. That's, you know, I think if I wasn't doing this, I would be teaching. So
Right.
yeah, please.
Well, we have all your contact details, so expect some kind of response.
Absolutely. Cool.
Thank you so much for sharing your time with us.
Oh, thanks for having
me. I learned a lot about GraphQL, which I was wanting to do, and I'm going to try out your tool. So this is going to be awesome. So thank you. Thank you for the detailed explanation and the demo.
Yeah.
And we'll talk to you online.
Okay.
I think that's it. Thank you very much for coming out. Check us out on all our... Just in case you didn't hear that, there was clapping. And we'll check us online for our next meetup in May and all the details associated with that. So thank you again. Thanks, Jared. And thank you, Simon.